Welcome back, everyone. We're going to be solving LeetCode 429, N-ary tree level order traversal. So we're given an N-ary tree. We need to return the level order traversal of its nodes values. So this is going to be our classic breadth first search algorithm, but instead of only having nodes in our tree, right, an N-ary tree has a children array at each level, right? So we're going to have to account for that, but otherwise it's just going to be the same as a breadth first search. So we will implement a DQ from our collections library, import DQ. So we'll set that up, and that will be equal to DQ. What will it contain? It will contain the root node. Okay, so now it looks like they want us to put each level inside of an array and return that as an output. So we will have return output equal to res. Now all we have to do is just run our breadth first search. So we'll say while the length of our queue is not equal to 0, what are we going to do? We are going to define a level equal to an empty array, and then we will loop through all of the nodes in our queue. So we'll say for I in range length of our queue, what will we do? We want to grab the node. So node is going to be equal to queue.pop_left. Now we want to check and make sure that the node is non-null, right? So we'll say if node is not none, what do we want to do? We want to append that node value onto our level. So we'll say level.append the node.val. Now we also want to check to see if this node has any children. If it does, we need to add those children to our queue. So how do we do that? Well, we can just simply say if node dot, we'll say if the length, to make it more readable, we'll say if the length of node dot children is not equal to 0, meaning we do have children, what will we do? Well, all we have to do is loop through this array and append each child onto our given queue. So we'll say for child in node.children, we just append that child to the queue. So we'll say queue.append that child. Okay, now after all of this executes, what do we want to do? We want to exit this for loop and check and make sure that this level contains nodes on it. If it does, we append that level to our resulting array. So we'll say if the length of level is not equal to 0, we will do res.append the level. And then at the end, we can just simply return our resulting output array. So let's run this. Perfect, so it does pass both test cases, so we'll submit this. And it does pass the submission tests, awesome. So time and space complexity. Space complexity is going to be bounds to the length of the queue plus the length of our resulting output. And I don't think I've ever mentioned this on this channel before, but on LeetCode, they generally don't count the output variable or whatever you're outputting as taking up space. So when LeetCode is concerned, it's just going to be the length of the queue. So it might be something to ask your interviewer if they want to count the space for both the queue and your output. But I've generally just been saying the output length plus the queue, and I will continue to do so. Okay, time complexity. That is going to be O of n, right? We have to loop through every single node within our tree, and we're essentially doing a breadth first search, right? So we're going to touch every node in our tree at least once. So that'll leave us with a time complexity of O of n and a space complexity of the queue length plus the resulting output length. All right, that'll do it for LeetCode 429.